year 2014, set 3 electrical question number 42. The complex power consumed by a constant voltage load is given by P1 plus JQ1, where P1 is in the range 1 and 1.5 kilowatts and Q1 is in the range 0.5 to 1 kilovolt ampere reactive. A compensating shunt capacitor is chosen such that Q1 is less than 0.25 kVAr, where Q is the net reactive power consumed by the capacitor load combination. So now the reactive power in kVAr supplied by the capacitor is, for NPTEL reference you can refer to lecture number 8, improvement of power factor by capacitors, of the NPTEL course Power Quality Improvement Technique by Professor Ovik Bhattacharya, Department of Electrical Engineering, IIT Roorkee. So now coming to the useful data, you know that with respect to load, if a load is of lagging nature, then it is inductive dominant, and that it absorbs reactive power, that is it needs reactive power, so it absorbs reactive power. And with respect to load, if something is absorbed, it is positive, and with respect to load, if something the load is delivering back to the source, then with respect to the load it is delivering positive reactive power, so Q is positive if it is delivered with respect to load. Now with respect to source, if it is delivering reactive power, that means the load which is connected to that source is inductive in nature, and hence with respect to the source that Q is positive. And if it is absorbing, that is the load is delivering reactive power to the source and the source is absorbing reactive power, that means it is negative, because with respect to the source, if it is absorbing something, it is negative. Now always remember, a lagging load absorbs reactive power and a leading load delivers reactive power to the source. Now with this knowledge, if you come to the problem, then you see that it is given that the load before the capacitor was connected, the load was consuming reactive power somewhere between 0.5 to 1 kilovolt ampere reactive. Now after connecting the capacitor delivers reactive power and helps in reactive power compensation such that the source power factor is maintained. So if you connect the capacitor, it delivers some reactive power, and hence the maximum reactive power that the load needs from the source is now less, and it is maximum 0.25. so the design should be made such that the load does not drop beyond 0.25 kilovolt ampere reactive power from the source. Since it needs maximum 1 kilovolt ampere reactive power and 0.25 is the limit that it can draw from the source, so the amount the capacitor has to supply maximum is 0.75. So 0.75 is the reactive power supplied by the capacitor. 1 kVAr is the maximum reactive power that the load draws, and 0.25 is the allowed limit that it can draw from the source. So remaining power the capacitor has to supply, Q capacitor max, is 1, that is the reactive power demand of the load, maximum demand, minus 0.25 that it can draw from the source. Remaining has to be supplied by the capacitor, so that is 0.75 kilovolt ampere reactive. So 0.75 is the answer. Thank you.